Hi everyone, welcome back to the Bioinformatics Coach channel. In today's video, I'm going to show you how you can use Python to get codons from a sequence. There may be times where you have a sequence or sequences and you may be expected to get codons and then maybe perform some tasks such as getting the codon frequencies, etc. So in this situation, it's important you learn programs so that you can use these programming languages to help you get the tasks done. There are tools, of course, to get the codons, but if you have, let's say, hundreds and thousands of sequences, then it's much better to use programming languages like Python to help you get the tasks done. So let's proceed. So let's just switch to the Jupyter notebook. Yes, so that's what we are going to do. So with this tutorial, we are going to look at this sequence here. Let me just proceed. Let's check. Okay, so we are going to look at this sequence here. What we are going to do is to generate codons. Okay, we are going to get the codons from this sequence. And by the way, for those who are not biologists, codons are a codon is a sequence of 3 nucleotides that code for an amino acid. So I would advise that if you are not a biologist, try and then learn about the central dogma of molecular biology. That will help you to understand the codons. So let's proceed. So what we have here is a sequence, and what we are going to do, let me just get this here. What we are going to do is to write a Python code to get the codons, and we are also going to count the number of codons present in this sequence. We are also going to count the number of CCUs. This is like a codon present in the sequence. And then we are going to count the number of start codons, number of stop codons, and we're also going to replace all stop codons with a star symbol. Okay, so this one here, I placed it there because sometimes, you know, with codons, we have start and we also have stop codons. Stop codons do not code for amino acids. So sometimes if you want to write the codons or if you want to link them with their respective amino acids, then there will be no amino acid for the stop codon, so we need to still represent it with a character or symbol. And so I'm going to show you how to do that so that everything fits in nice. Okay, so let's proceed. And by the way, for this tutorial, you only need to have Python installed on your PC. That is it. So you can use Jupyter Notebook, you can use PyCharm, you can use any Python environment. Command line or ID, any of them should be fine. So just make sure you have Python installed. And I'm going to leave this sequence also in the description box so that you don't type them. Okay, so if you don't have Python installed, you can still run this using your browser. You just need to go to Google Colab, which is here. Okay, so Google Colab, I'll leave the link in the description box. So just make sure that you have your Google account and you have signed in, and then you'll be able to use Google Colab, which allows you to run Python with your browser. So just check it out. It's a cool platform. Okay, so let's proceed. So we have our task here. So how do we start? Okay, now with codons, if you are going to generate it, we use the strategy indexing and then slicing. I have already covered slicing and indexing in a different video, so you can just go and then watch that video. Just click the link right up there to just watch it, or you can also check the link in the description box and you'll be able to get the basics for this tutorial. So let's proceed. So we have our sequence here. So if you are going to generate codons in Python, we need to get our sequence, which we have. We also need to get the length of the sequence. It's very, very important because what we are going to do is index and then slice. So with the slicing, what we are going to do is that because codons are in triplets, okay, it's always a sequence of 3 nucleotides. We are going to just be iterating over this sequence here, for example, and then we will just be jumping in intervals of 3. So every 3 nucleotides becomes a codon, and then we just put them in their respective places. Okay, so that's how we are going to do it. So let's proceed. We have our sequence, so let's just run it first. Okay, so now we have our sequence activated. Let's just check. We need a length, so we will start with the length first. So let's get the length, which is len sequence. We need that information. Okay, so what's the length? Let's check. It's 30. Okay, so we have this information. Now let's proceed. We still have to get this first point down. Okay, so let's check. Now that we have the lengths, we are now going to use loops to get the codons. So what we are going to use to get each of these every three nucleotides into a data structure, or let's say we are going to put all of them in a strange container. So that's what we will do. So let's just look at it. We have our length first. So this is what we'll do. We will first create an empty list. So we say codons, and then we'll put it here. So this is our empty list. We need that first. And after that, we use a for loop. So we say for I in range 0, 30. So that's the start and then the end. And then because codons are what's 3, a codon comprised of 3 nucleotides, we need to set a stride here, which is 3. So that means we are jumping 3 places. So once we have this, then we can proceed. So we can say codon equals, we need to have our sequence here. So you can say sequence I is to I plus 3. This is what we have at the moment. So we are continuing. Once we have this, this becomes our codon. Okay, so now we are going to extend this code, but let's just print what we have here before we proceed. So this becomes our codon. So let's just print this. We will come back to this one here. For now, let's just print first. I will come back to this. So we have our sequence, we have our I plus 3. So that means wherever we are, plus 3. So here, plus 3, we have it this way. And then the next one will start from here. And then we proceed. So it's in threes. And by the way, just make sure you watch the video on indexing and slicing. That will help you to understand what I am doing here. So please do that. The link is in the description box. Okay, so let's run this to print the codons. So let's run this. Okay, perfect. So we have them printed for us. So these are the codons. So you can check here. If you do it manually, you will see that everything is okay. So that's what we have here. Let's just clear this output. Because in the real world situation, you will need the list of codons. So we need to put the codons we get into a container, sort of. So that is why this list here, this list object is here. So we are going to put it here. All the codons will be added here. So once we have our codon, we say codons.append, and then we append into this list. And I have covered another tutorial that shows you how to use list in Python, so you can just watch that as well. I'll leave the playlist in the description box. For I have a separate playlist for Python for bioinformatics. I have beginner level and I also have intermediate level, so you have all those videos there. So let's proceed. So now I have appended it here. So that is about it. So I'll run this code. Perfect. So I have the first step completed. Write a Python code to get the codons. That is done. Now the second question is count the number of codons present in this sequence. That is this sequence here. Okay. So because we have the lists object here, let's just display it codons. These are the codons. So if you want to find the number of items in a list, we use the len. So we say len codons. That will give us 10. So this 10 is what's the number of codons. And by the way, the length of the codon is 30. So if you have 10, that's it, because codons are what? In threes. So 3 times 10 is what? 30. So that is what we have here. So here, let's just say number of codons equals len codons. Let's just put it in. So now we can just print and say number of codons is, and I'll do this. This is D. I'm using this so that those using Python 2 can still reproduce the code. So I say number of codons. So I'll run this again. So number of codons is this, like a strange formatting. So I'll do that here. Okay, so number of codons is 10. Perfect. Now let's go to the next point, which is count the number of CCUs. Okay, so here, if you want to count, we just have this pattern. So I'll just use this one. It's CCU. Okay, CCU. So to count the number of items in a list, we say what? The list objects, in this case codons dot count, and you specify the item of interest, which is this one here. So what? We just run it. Perfect. So we have 2 of them here. So 2 of the codons are CCU. Okay, so CCU count is what? 2. So what we are doing now is getting the codon frequency. If if I'm right. So that's what we have. So the codon count here, CCU, we have CCU here. There's also another one here. So we have it done. So that is what's the number of CCUs. Now let's look at what? Count the number of start codons. Now for this tutorial, we are using the universal genetic code. So the start codon is going to be AUG. Let me just confirm here first, so that we are all on the same page. So just hold on for now. Okay, let's just check. So yeah, okay, so I think universal or standard. Let me see which one is more appropriate. Okay, so let's just use the standard genetic code. For the genetic code, there are a number of schemes. So we are using the standard one, or the universal one. I'm using this words interchangeably. They all mean the same thing here. So with that scheme, the start codon is AUG. So that means that here we are going to count what? AUG. So let's do that. So to count is the same thing we did here. At this time, we change this to AUG. That is what we have here. So we have 1. Okay, so that is here. Okay, let me just put this comment here, because I will upload this notebook to my GitHub repository for those of you who want to get it. And then let's get this number of, let's just check the question. Okay, yeah, let's make it simple. Let's number of start codons, and then let's check the other one, which is number of stop codons. Yeah, so for the stop codons, there are three. We have UAG, we have UAA, we have UGA. And so if you are going to count, that means we need to count all these. Okay, because the question says number of stop codons. It did not specify which of these stop codons, so we are going to count all of them. So let's just check number of stop codons. So we will use a similar approach here, plus. So here it's UAG, that's the first one, and then the second one is UAA, and then the other one is UGA. So we have them here. Let me just confirm first. Stop codons. Let's just confirm here. Yeah, so we have we have UAG, UAA, and we have UGA. Perfect. So that is it. So once we have it like this, we just run it. So we are counting the number of UAGs, number of UAs, and then codons, UGA. So the sum of these will give us the number of codons. So that's it. So let's run this. Okay, so we have 0. Okay, so we have 0. So the number of stop codons is 0. Okay. Okay, perfect. So that's okay. So number of stop codons is 0. That means there's none. And so that means this question we will have to skip it because there's no stop codon, so we can't replace them with the star. So what we are going to do is to create another sequence, and I'll use that to demonstrate how to replace this stop codons with star. So I'll just do that here. Sequence 2. Let me say replace all stop codons with star. Okay, so that's it. So let's proceed. So this one here, let's just modify. I'll modify some of the codons here. Let me just modify the last one here. Let's say UGA, and then let me modify another one here. 1, 2, 3. UAA. Okay, so let's just look at these two. Okay, so here we will still repeat the same steps like this one here. Let me just come back here. I'll repeat the same steps here, but then what will happen is that we are going to issue another statement here. We call it the if statement. So we will use the if statement. So here, because these are the stop codons and we are replacing them with star, what we are going to do is that there are a number of ways you can do this, but then because we are generating codons, we will just use this approach. There are other ways as well, but if there's time, I'll cover that. So let's keep it simple. So okay, so this is the actual command. Let me just go over again. I'll just do it here. So to replace the stop codons with a star, we issue our if statement. So with the if statement, you will say if codon equals UAG, which is one of the codons, or codon equals UAA, or codons equals UGA. Then codon, let me just call it, this is codon. Then codon equals star. This is how it's supposed to be. Okay, there are 3 stop codons here. So the code here has been written to factor in all these stop codons. Okay, so that's what we have. So if the codon is equals to this or this or that, then the codon is equals to star, and then we append it here. That is what this code is doing. So let's run it. We have this code here. Yeah, so now we have the code here, but then we shouldn't forget that now we have what, sequence 2, and therefore we also have to change this one here to sequence 2. Okay, so if you don't change it, then we get this output. Let's just run this code here again. Okay, so this a classical example of garbage in, garbage out. Okay, so because we are using sequence 2, we need to also specify it. Let's just run this one. Even though we have done this code, okay, this code is correct. We have it done nicely. If you run this, let's run this. We are going to get something like this. Okay, this is because we are still using the first sequence, but we need to change it. So let's change it. Let's clear the screen first and then change it, and then you'll get what we want. So let's do that. So this is sequence 2. So we will change it, and then we will make the query. So that's codons. Perfect. So now we have it done. Okay, so now we have been able to what? Replace our stop codons with a star. So this is how Python can make life easy for us. Okay, and when we are analyzing sequences. Okay, so if you have this code, then it becomes easier to extend it so that you can use it on other sequences at all. You may have hundreds or thousands of sequences, and so it's important that you learn programs so that you can use that to process your data. Now let's try one more stuff here. What we did was to just write the codes, but then in the real world situation you reuse the codes, and so we can create a function that will help us to use the codes on different sequences. So let's try that. I have covered a separate tutorial on functions, by the way, so you can just watch that to learn more about how functions can be used to repeat codes, but I thought I'll share this one here. So let's do that. Let's get this last one here. Let's check. We have Python function. So we say create a function to get the codon, to get codons from from a sequence. Okay, thanks. If yeah, so I figured the problem out. Thanks. Okay, so let's get the function. So that's what we will do. We will just create a function here. We say def get codons, and we say seek. So this will serve as a placeholder for all the sequences we want to process. So this is a function, so it's a block code. We are going to use this one here. I'll modify this code. Okay, yeah, so now I'm going to use this. Let's check here. So this function will accept a sequence, and then it will repeat the same instructions here, and then return codons. It will return the codons for us. So this is how we do it. So let's just cross check to make sure that everything is fine. So this is seek, so we will use seek here, or let's just make it sequence just so everybody can understand. So we have our codons, and then we have this here. So this 30 here will also change. Okay, formerly we're using 30 because the length of the sequence here was 30, but if you are using it in a function, then we need to make some change. So length is equals to length sequence. Then we can put the length here. Okay, then we put that length here. So for this one, let's just remove the this requirement. Let's just make it generic. We just want just the codons, nothing more. Okay, so let's make it simple here. So we have it this way. So codons, we have our list, the length, we have our length sequence, and then we have our loop here. We start 0 up to the end, an interval or stride or step of 3, and then we made a query, okay, specifying the region, okay, of interest. That is what we have here, and then we append here, and then finally we return it. For functions, by default, variables cannot be accessed, okay, they are only accessible within the function. And so to be able to get the variables, we need to use the return keyword, so that that variable or that value will be pushed out so that we can access it. That is what we have here. So now let's just call this function. We will still use this one here. Oops, let me check. We will still use this one here. We will still use this sequence here to tests. Okay, so we say get codons. Now let's just test this. If you just write the get codons like this, you are going to get an error. Let's just check. Let's check. We are going to get an error because 1, we have not activated this function, and 2, we have not even specified any sequence here. Okay, so let's just run this first, and then let's just get this function again, and then we are going to get another error. Okay, this error is because we have what's missing one required position arguments. Okay, this is the argument. Okay, so we need to specify it. We need to give it a sequence to work with. Otherwise, we will not get any results. So let's now do it again. Let's clear this outputs. And then now let's specify the sequence here. The sequence here, and then let's get the outputs. So let's try this. Perfect. So now we have it here. Okay, so that is done nicely for us. So you can put any sequence there, and then you will still get the results. And so if you have it this way, then you can also repeat this for lots of sequences of your choice. So now let's try something else here. Let's just say we have sequences. Let's just say AUGGUAGCCCUAAAG. This is one sequence. This is another sequence, AUGGUAGCCCUA. Let's try another one here, UUCCAA. We are just using random sequences. Let's try it this way. You just want to make sure they are all divisible by 3. Okay, so that's it. And by the way, in real world situations, your sequences may not be divisible by 3, so that means that some nucleotides will be left out, but those things you will need to investigate and then decide what works best for you. For now, and because of reproducibility, that is why I'm using sequences with length divisible by 3. So take note of that. Let's just check to make sure that they are all divisible by 3. Okay, so if you have this sequence like this, then you can use a loop to iterate and then get the codons for each of them. So we can say for sequence in sequences, and then we call our function, and then we supply it with a sequence, and then we will get the result. So let's run this. Let's just check. Let's make sure we have it there. So we have codons is equals to get codons sequence. Yeah. and then we just print it. Let's say print codons. So let's run this. Perfect. So now we have it done nicely for us. So using this function here, we'll be able to reuse the codes when we have multiple sequences or when we have several sequences. So this is how Python makes life easy for us in bioinformatics. Perfect. So that's about it. Let's just proceed, and I'll make this notebook available on my GitHub repo, one of the repos, and I'll leave the link in the description box once that is also done. So take note of that. Now let's proceed. Okay, all too soon we've come to the end of this tutorial, and I believe you've been able to learn something new as well. So let me also get your comments. If there are things that can be improved, just let me know and I'll try to add that in the next video. So that'll be all for this tutorial. Thanks for watching, and I'll see you in the next session. Goodbye.